On this lesson, we're going to be looking at function families. So the key concept at the beginning, it says a blank is a set of functions whose equations share a similar form. So this is called a function family. Common attributes will also be evident graphically, so you'll also be able to determine graphically what type of function it is. So then the next part, it says a blank is the simplest form of an equation representing a function family. So if it represents the function family, that is the parent function. So the parent function represents all of those graphs or equations that are a part of that function. The blank of a function is y equals f of x is at the point at which the function reaches the smallest y value. This is called a minimum. And then the blank of a function y equals f of x is at the point it reaches the largest value is the maximum y value. Identifying a function family from an equation by examining its structure and comparing it to its parent function. So we're going to be identifying different types of functions based on the equation. So example 1, all of these we're going to be identifying the function family, and then we're writing and graphing the corresponding parent function. So this first one, this is called linear. The parent function for linear is y equals x. And then that parent function looks like this. So we're just going to sketch it there. The aspects of the function, so how do we know is it linear? Because 1 is the greatest exponent of the variable. So if you look at it, we have an x, and it's x to the first power. So that's always going to be a linear function. Okay, so the next one, notice we have a cubed. So this is called cubic. The parent function is y equals x cubed. And that looks like this little squiggle line. The reason we know that this is going to be cubic is because 3 is the greatest exponent of the variable. So anytime your highest exponent is a 3, that's called a cubic function. The next one, notice this one we have a square root, so this is called square root. The parent function for that is y equals the square root of x. That is an array, so it starts at 0 and it curves to the right. The reason we know this is a square root equation is because it takes the square root of the variable. So if the variable is under the square root, that's considered a square root function. Okay, so moving on. Another type of function that we're going to be looking at, notice we have that t as our variable, and that's the exponent. So this is called exponential. The parent function for that is y equals, we're going to call it b, which is called the base to the x power. So that is your parent function equation. So an exponential graph on your parent function looks like this. So it's a curvy line that is getting closer and closer to the x-axis. That's called an asymptote. As your graph is getting closer and closer to something but never actually touching it, that's called an asymptote. So we do have an asymptote on exponential. The reason we know this is exponential is because the variable is the part of the exponent. Okay, so the next one, notice it's not a square root, it has a little 3 there, that's called a cube root. So your parent function for that is y equals the cube root of x. So it's kind of similar to your cubic, except it is still a squiggly, but it goes horizontally instead of vertically. So it's increasing from left to right horizontally. How we know that this is a cube root, it takes the cube root of the variable. Okay, so the next one, notice it has a variable and it's squared. So this is called a quadratic. You've probably seen this in, or you have seen this in Algebra 1. Quadratic, the parent function for that is y equals x squared. And it is a parabola. How we know it's quadratic is 2 is the greatest exponent of the variable. Okay, the next one we have y equals log of 5x. So you've probably never seen this before. This is a logarithmic graph. The parent function for that is y equals log base b of x. This is similar to the exponential. Remember the exponential up here approached the x-axis. This one's similar, but this is actually approaching, well, it should be curving. It's approaching the y-axis. So there's asymptote at the y-axis on a logarithmic function. How we know it's log, it takes the log of the variable. We have two more. Okay, so the next one, notice that x is in the denominator of a fraction. So anytime we have a variable in the denominator of a fraction, this is called rational. Rational means fraction. The parent function for that is y equals 1 over x. This graph, it's like two separate pieces. You're going to have an asymptote vertical and a horizontal asymptote. So it's going to be two different sections on a graph. How you know that it's rational, you're going to have the variable in the denominator. Okay, so then this last one, the vertical bars we've already talked about, that's absolute value. So this is an absolute the parent function that represents all of your absolute values is y equals the absolute value of x. Remember, we've already talked about that graph. It should be a v. And how we know on the equation that it's absolute value, it takes the absolute value of the variable. Okay, so those are all the different types of functions that we're going to be looking at in Algebra 2 this year. So you need to be familiar with all of them. You need to be able to recognize them on the equation and then also on the graph. So now let's take a look at the back. Okay, so we're going to be identifying a function family from the graph. So it says identify the function family name that corresponds to the graph below. So this first one, if you remember back from the front, this is a cube root graph. So it asks what aspects of the function graph indicate that it belongs to this family. So remember we talked about it's a squiggly I'll just put it squiggles horizontally. Okay, so the next one, it's two separate pieces. So if you remember from the front, the two separate pieces, one that's called rational. And the aspect of that is, I'm just going to put two separate pieces. Okay, so this next one is array here, so it does stop. So this is a square root graph. So I'm just going to put, it's array, so it has an endpoint and then it's continuous. All right, so you're going to have to be able to look at a graph and determine what type of function it belongs to. All right, so let's take a look at this next example. So we're going to use the information provided to represent the parent function in multiple ways. So we're given, in this part, we're given the table. We're going to plot the points, and then we're going to be able to visually see what type of function it is. So let's go ahead and plot them. -6, 6, -4, 4. That should be a -2, 2. 0, 0. 2, 2. 4, 4. Oops. And 6, 6. So notice it's a V. So I'm going to go ahead and connect my points and draw arrows at both ends. So this would represent the absolute value. The equation for the parent function is y equals the absolute value of x. And then we're finding the domain and the range. So it doesn't specify on how to write the domain and the range, so I'm just going to use interval notation, but you're welcome to use whatever notation you like. So on domain, notice it's continuous to the left and right. So it'd be -infinity to infinity, or all real numbers if you want to write it like that. And then the range, if you notice, it starts at 0, and it keeps going to infinity. So it does include 0, and then we need a parenthesis. Or you could write y is greater than or equal to 0. Okay, so it says what makes this function special. So notice that it is only using positive y values. The reason for that is when you take the absolute value of something, it's always positive. You're finding the distance the number is from 0. And then it says, how can you tell it belongs to this family? Because of the V. So it is a V shape. Okay, so those are the different functions that we're going to be looking at in Algebra 2 this year. So if you have any questions, please ask.